everyone. My name is Rubeda Ravindra Kulkarni and my PRN number is 20UET063 and my assignment topic name is hybrid equivalent module of a BJT. So we will discuss how to derive the hybrid equivalent module of a BJT using hybrid module, and we will derive its two parameters. So let's see how to derive it. So this is a hybrid equivalent module of a transistor. We have to derive this, but this is a hybrid module of a transistor. So to convert hybrid module of a transistor into hybrid equivalent module of a transistor, we have to use common emitter configuration, because the common emitter configuration has high current gain as well as high voltage gain. So the high current gain and high voltage gain, it is useful for the amplification of a transistor. So we will draw common emitter configuration circuit. Here VCC is connected and this is collector resistor RC. This is collector base emitter. Emitter is grounded, and this is emitter resistor RE and bypassed capacitor CE, and this is load resistor RL, and this is coupling capacitor C out, and here this is a coupling capacitor C in. A source voltage Vs is connected, and R1 and R2 are voltage divider circuit. Here a bypass capacitor is used. This is a condition in which the current through the emitter will does not flow through RE, it will passes directly through capacitor. This condition is called as bypass capacitor. And there is also another condition, unbypassed. Then there the current will directly flow through the emitter and connected to the ground. So now we will discuss guidelines for hybrid equivalent module of transistor. First, we will draw the above circuit and then insert H module of transistor in circuit to become equivalent H module of transistor amplifier. Now, first step, we have drawn the circuit. Second, we will make short circuit the all capacitors present in the circuit. Then make all supply equals to 0, that is connect VCC to the ground. And fourth step, then replace the transistor with H module of transistor. So here we will short all the capacitors which are connected in the circuit, means they will short, means there is a straight path. Then we will make supply equals to 0, means we have to connect this VCC to the ground and replace this transistor with a H module. So the circuit becomes Now here the resistor R1 is connected to the ground, and here the capacitor is short, so Re is in parallel with the short circuited capacitor C. So we know large is parallel with small, the answer will be small, so Re will be short. Re parallel C. Now this collector resistor will also connected to the ground, and this VCC is connected to the ground. So the hybrid equivalent module of transistor becomes this is Vs, this is Vs is equal to Vi, and this is Ri, this is R1, R2, sorry, here is Hi, this is HRV2 and HF I1, this is 1 upon HO, this is RC and load resistor RL, this is V out, V. So we replace this transistor by the hybrid module of a transistor. So now there are 4 types of parameters. First, current gain AI, second, input impedance Ri, third, voltage gain AV, and fourth, output impedance RO. So we will derive 2 parameters, which are first, current gain AI, and second, input impedance Ri. Now we know current gain AI. Basic definition of current gain is that output current to the input current. Therefore, AI is equal to I2 divided by I1. But in the circuit, I2 equals to minus IL, or IL equal to minus I2, because they are same in magnitude but opposite in phase. From the circuit, we know I2 equal to HF I1 plus V2 HO. As we want I2 in the form of I2, we will need V2 is equal to IL RL, where IL equal to minus I2. Therefore, V2 equal to minus I2 RL HO. Therefore, I2 equal to HF I1 plus minus I2 RL HO. Therefore, I2 equal to HF I1 minus I2 RL HO. Therefore, HF I1 is equal to I2 plus I2 RL HO. Therefore, HF I1 is equal to I2 into 1 plus RL HO. Therefore, I2 divided by I1 is equal to HF divided by 1 plus RL HO. Now the second parameter is input impedance. So it is basically ratio of input voltage to the input current, that is R1 is equal to V1 by I1 by Ohm's law. Therefore, from the given circuit, by applying KVL at port 1, we will get V1 is equals to HI I1 plus HR V2. Therefore, we will put this value in above equation. R1 is equals to HI I1 plus HR V2 divided by I1. Therefore, R1 is equals to HI plus HRV2 divided by I1. As we want V2 in the form of V2, therefore V2 is equals to minus I2 RL. Therefore we know current gain of the circuit AI is equals to minus I2 divided by I1. Therefore minus I2 is equals to AI into I1. Therefore V2 becomes AI I1 RL. Therefore R1 or Ri is equal to HI plus HR AI I1 RL divided by I1. Therefore Ri is equal to HI plus HR AI RL. It is the input impedance of the given circuit.